Hello friends, today's session we are going to discuss about generalized circuit constants of short transmission line. So before going to that, in a previous session, you just go for my YouTube channel. We discussed about how to get the generalized constants, that is ABCD parameters, and we discussed about the conditions of symmetrical and the condition of reciprocal. So now we'll be going to apply for that to the short transmission line. So before going to start about the short transmission line, we already know about the short transmission line. So here in case of short transmission line, the effect of line capacitance is neglected due to short distance. Only will be considering the line is having series impedance. Line is having series impedance Z, that is nothing but R plus JXL. Okay, and now we'll be going to know the I'll tell you in a simple way. Here what we are doing will be just finding the ABCD values, that is the unknown values of ABCD, by comparing with the equations of short transmission line. How we are getting the equation in a short transmission line? It's very simple. Just by looking at the circuit diagram, you write the expressions what and all will be getting. For example, just look at the current IS which flows from sending end and IR which flows to the receiving end, so that the both currents are same because of this series connection. So that IS equals to IR is one expression, and other expression we have to write VS by applying KVL. So that if you are applying KVL, what you are getting? Vs equals to Is into R plus Is into XL plus VR. So that this R plus JXL is nothing but Z. So if you want to write in terms of impedance, either I can write Is into Z plus VR. So here Is equals to IR, so that or else I can write here Vs equals to Z into IR plus VR, or else VR plus I into ZR. So after getting this, we'll be going to compare these expressions with the standard equation of generalized constant, that is ABCD parameter. So this we are getting from circuit diagram. I'll give this Vs as equation number 1 and Is equals to IR as equation number 2. Similarly, the standard expression of line parameter Vs is equation 3 and Is as equation number 4. Now it's very simple. You have to compare a standard generalized constants along with the short transmission line parameters. So short transmission line parameter, from equation number 1 we can get Vs equals to Vr plus IR into Z. Compare with the equation 3. So Vs equals to A into Vr plus B into IR. We can get the unknown parameters A, B. So what is A here? A is nothing but 1 and B is nothing but Z. So that A equals to 1 and B equals to Z we are getting. Similarly, compare equation 4 with the equation 2. So Is equals to CVR plus DIR with the Is equals to IR. So here the value of Is equals to IR is nothing but D into IR is nothing but value of D is 1, C into VR is 0, so that the value of C is 0. So you can get A equals to 1, B equals to Z, C equals to 0, D equals to 1. Once if you are getting the values of circuit constants in short transmission line, so next step or the next thing is to remember a condition, that is a symmetrical condition and reciprocal condition of the ABCD parameters. When a circuit which is said to be symmetrical, in case A equals to D, look at the value of A and D. A is 1 and also D is 1, so that the circuit is symmetrical. So to get the to get the reciprocal, what we have to do, we have to uh, simplify. We have to get the proof that AD minus BC equals to 1. By substituting the value of ABCD in expression AD minus BC, we should get 1. So that here we'll be substituting. First is condition is symmetrical when A equals to D, A equals to 1 and D equals to 1. Next is we'll be going to check whether the circuit is reciprocal or not. To check that, substitute the values of ABCD values in the expression AD minus BC, where A is 1, D is 1, B is Z, C is 0. So this terminal becomes 0. We can get AD minus BC equals to 1 is nothing but reciprocal. So this is about circuit constant of short transmission line. So if you have any doubts regarding this, please give your doubts in the comment box. Thank you so much for watching.